Okay, so page 29, and remember that yesterday the key thing that we had learned was understanding what this thing p-value is. Okay, so what the p-value definition is, and then, doing all of this stuff, parameter, null hypothesis, and all that kind of stuff review. So we'll do this first one together, and then there will be 5 problems that you do on your own today. So here we go. All right, this first one. In the 1980s, it was generally believed that autism affected about 6% of the nation's children. Some people believe that the increase in the number of chemicals in the environment has led to an increase in the incidence of autism. A recent study examined 384 children and found that 46 of them showed signs of some form of autism. Is there strong evidence that the level of autism has increased? All right. So what is the parameter? What is this problem about? P equals proportion. Okay, good. Proportion of the nation's children and I'm actually going to use the same wording that they use, that show, thank you, proportion of the nation's children that show some form of autism. All right, so that's what we're talking about. So now, null hypothesis wise, back in the 1980s, it was generally believed that that proportion was how much? 0.06. Very good, 6%. And so I would just write that as 0.06. Okay. Now, there's been some speculation that because of chemicals, or I know I hear a lot about things with vaccines and all that or whatever, they're not going to say what the cause is, but whatever is happening, they think that the proportion has what? Increased. So we're going to say P is greater than 0.06. Now, we're going to see if we have significant evidence that the proportion has increased. And so here we go. Okay, so we've done these things before here. What is this P? Good. This population P is 0.06, which means that the mean, the center of all the samples, is also centered at 0.06. Okay. All right, what is the sample size? What is N? Okay, very good. It was 384, it said up there. They took a sample of 384 children. Okay, how about this standard deviation? Do you remember that this formula?
Square root of P and then 1 minus P.
Good. Okay, there's our formula. I'll go ahead and put in those numbers. 0.06, 0.94 over the 384. Now, there has been some problem with, the accuracy of you guys trying to solve this, so you might put it in your calculator right now and see if you're being able to do that. I wouldn't put it past you going ahead and computing this inside, and then after you compute the entire inside, take the square root of that. That way there's no question as to whether or not you've gotten the order of operations correct. It should give you the answer 0.012. If you got that, then you did that correctly in your calculator. All right. Now, P hat. What does P hat stand for? Good. Sample proportion. Excellent. Perfect. So the sample results that we got was 46 out of 384. And that number is 0.12. So we found a sample, and 12% of it had autism. What do you think about that number? Do you think that means that the autism rate has increased? That number 12%? It used to be 6%. Okay. Well, it could be bigger. We don't know how much bigger is way, way bigger. So that's what we're about to figure out now. So how do we do that? How do I figure out how much bigger is way, way bigger? Perfect. Got to find that z-score. And so remember, this is p hat minus your p over your standard deviation of p hats. All right, so that is 0.12 minus your 0.06 over that 0.012, and that number comes out to be 5. I think so. 5 exactly? Cool. All right, so it came out to be 5 exactly. So, hey, what does a z-score of 5 mean? Let's remember what normal model stuff means. What does a z-score of 5 mean? You don't have to do this, but I'm reminding you, 1, 2, 3, 4, 5. That means you got a sample all the way out here. The null hypothesis is at 0.06. You got a sample 5 standard deviations away from the null hypothesis, which is way huge, okay? So now how do I get my p-value, my probability? Nope, norm CDF. And we are wondering if it has increased, so therefore we're going from what to what? 5 to 99. Okay, now I want to go ahead and have you do this because, again, there's an issue with what people are seeing on the calculator and understanding what's happening. So I'm going to go second vars, norm CDF, from 5 to 99. I get this number, okay, and people, what do you notice? Is this 2.87%? No. Okay, guys, you can't have a probability that's 2.87 something. That's 287%. If you see something, a number that is over 1 right here, then you've got something, must have something at the end that's order of operations. So this is essentially 2.87 times 10 to the negative 7th. Is that really big or really, really small? Super, super small. So I'm going to put that's about 0%. Yep, you can just put 0%. So let's remember my notation, the probability of getting a p hat that is greater than 0.12 is 0. It is. All right. So last thing is what we learned yesterday, which is the interpretation of your p-value. And so what I have done here is I wrote this little p-value statement here. And so we're going to write out the conclusion of this. And so I wanted to point out the part of the song that you replace with context. You know, the p-value is the probability. So we kind of replace this by saying there is a blank percent chance. Okay, so that's how we're going to start that. There is a 0% chance of getting this sample. In place of this sample, we're going to put the results that you got. So there's about a 0% chance of getting, what results did you get? 46 out of 384. Yeah. Or something more extreme. What's more extreme? A lot less or a lot more? More. That many or more autistic children. Okay? So that's what that is. 0% chance of getting this sample or whichever way is more extreme. Okay, now we're almost done. If the null is true. But I'm going to let you put, since you have done such a good job here of putting, that sample or more autistic children, you've got context in there, then I'm going to allow you to say if, and the null hypothesis says p equals 0.06. So see, here's what this is saying. Let me just say this one last thing, and then I'm going to let you do your assignment. You know what? If there really is still just 6% autistic children in the whole entire nation, then there was a 0% chance that we would have gotten that sample we got. say that again. If there right now at this time is still just 6% autistic children in the United States, then there's pretty much a 0% chance that we would have gotten that sample we got. So, you know what the deal is? Do you think there is still just 6% autistic children in the United States? Heck no. And that's the next lesson that we'll go to. We'll end up saying, so I'm rejecting that. I don't think there's actually 6% anymore. I think it's actually higher. But we're not to that. That's all we're going through today. That will be the next lesson. So your assignment is to finish the rest of this part 2, which is 5 more problems. It takes you through page 34.